So we're looking at problem 206, which is reversing a linked list. It is pretty self-explanatory. So if you're given an input that is this particular linked list, you just want to reverse that. So the way we're going to do it is we're going to take a particular node and we're going to change its next. So for me, when I initially looked at this problem, when I looked at this particular output, I was a little confused as to how I would do it, but it helped me to look at it this way. So if this is the input and this is the output, so what you would do is that you would take that particular node and just change what it points to. So the current node would just point to the previous node, and you would continue doing that iteratively till you reach the end of the linked list. So what is the time complexity of this? The time complexity would be of n because you're iterating through every single node, and the space complexity would be of 1 because you're not really taking up additional space more than just temporary variables. So let's get started. So you want two particular variables before you start the loop. You would want previous, so it would be initialized to null, and we will see why in a second. And then this node current, so this is a current node that we are trying to fix, and then that would point to head. So the while loop would be while current is not equal to null, you would want to continue changing what the nodes point to, and then in the end you would just want to return the current node. So in this case, first you would want to save what the next node looks like as a current dot next. And the reason why we are doing this is because we want to change what the current node points to, and before that you want to save that so that you can use that as the node that you're editing in the next iteration of the loop. So current next would be previous. So in this case, what you're doing is, if you look at the example here and we start with 1, you're taking this and you're pointing, you're storing the variable 2 in next, and then you're saying that current dot next, which is one currently, so you want to point that to the previous one. So in our case, previous is null, at least in the first iteration, so it would point to null. And then the previous node would become the current node, and the current node would become next. So let's try to understand what just happened. So you're storing the next node as the one that is being pointed to currently, so that we can use that as the current node in the next iteration of the loop. And then you're pointing that the current node that you have, you want to point it to the previous node so that you get something like this. At least in this iteration, the first iteration, it would look like this. You're just pointing towards null, which is the previous node, and the previous node would become current. And the reason why we're doing that is because we want to use that as a previous node when we come to the next node, and then the current node is assigned as the next node that we stored right here. So let's quickly run that and see if, why is this a problem? Where's the current dot next? So let's see. So while current is not equal to null, next is current dot next is equal to previous is equal to current is equal to next. Why is it pointing, why is it giving me an empty? So maybe if you return previous, because while, okay, yeah, maybe that is it. Yes, okay. So the reason why that was a problem was because this loops only breaks when you say the current is not equal to null, and only then it continues running. So you would still come here till the current is equal to null. So in that case, you would just want to return the previous, that would point at the new head of the linked list. So let's submit this and see if it's accepted. Yes, it is. And so this is a pretty simple problem if you understand how to picture it and how to change it iteratively. If you have any questions, leave comments below, and I would be more than happy to answer your questions.